Computers were supposed to be honest machines. You give them instructions, they execute them. Inputs go in, outputs come out. Clean, mechanical, trustworthy. That idea died a long time ago. Modern software doesn't tell hardware the truth. It flatters it, it stalls it. It makes optimistic promises it knows it can't keep. And when something goes wrong, it smiles and says, "Still working." Your CPU is asked to do 10 things at once, but software pretends it's doing one. Your storage is drowning in requests, but software insists everything is instant. Your battery is bleeding energy, but software claims it's being efficient. None of this is accidental. This is a carefully engineered illusion, one built so hardware keeps cooperating, users stay calm, and the whole system feels faster than it really is. The lie isn't hidden, it's designed, and once you see how this agreement works, you start to notice the cracks everywhere. To understand why software learned to lie, you have to go back to a time when computers were painfully honest. Early machines didn't pretend. If the hardware was busy, it just stopped. The screen froze. The keyboard did nothing. You waited. Sometimes for seconds, sometimes for minutes. And everyone accepted it because computers were rare, expensive, and slow by definition. Back then, software spoke almost directly to hardware. When a program asked the CPU to do something, the CPU did it. When it needed memory, it took it. When it finished, it said so. No smoothing, no illusion, no negotiation. That worked when computers did one thing at a time. Then everything changed. As machines got faster, we didn't make them calmer. We made them busier. We asked one chip to run dozens of programs at once, to play music while downloading files, to render graphics while checking email, to feel instant, even when juggling impossible workloads. That's when honesty stopped being practical. Modern operating systems became diplomats. They stand between software and hardware, translating demands into something survivable. Every app believes it's important. Every process thinks it deserves immediate attention. The hardware, meanwhile, can only do one thing per core at any exact moment. So the operating system lies on everyone's behalf. It tells apps they're running right now, even when they're paused. It tells the CPU it's under control, even when queues are backing up. It tells you that a task is almost done, even though the hardest part hasn't started yet. This is where scheduling was born. Not just task scheduling, but expectation scheduling. The CPU time is sliced into tiny pieces, milliseconds so small you never notice. Each app gets a turn. No one gets the full truth about how crowded the line really is. Memory works the same way. Programs are told they have access to more memory than physically exists. When they reach for it, the system quietly reshuffles, compresses, swaps, and pretends nothing unusual happened. Even storage lies. When you save a file, it often isn't written immediately. The system says done, then finishes the work later, hoping nothing goes wrong in the meantime. All of this deception has one goal: responsiveness. Not speed, not efficiency. The feeling that the machine is alive, attentive, and listening. The uncomfortable reality is that modern computing isn't about doing things instantly. It's about making delays invisible. And once you see that, you start noticing how much effort goes into hiding the truth. Here's where the quiet conflict begins. Because once software learns it can lie, it doesn't stop at small white lies. It starts negotiating, pushing boundaries, asking for more than it needs, because it knows the system will say no gently. Every app behaves like it's in a crowded airport, cutting into the boarding line while smiling. Just a little CPU time, just a bit more memory. I'll give it back later. Most of the time it doesn't. Take CPU usage. An app never says, "I need the processor constantly for the next 10 seconds. That would get it punished. Instead, it wakes up hundreds of times per second, does tiny bursts of work, and goes back to sleep. On paper, it looks polite. In reality, it's exhausting the hardware. Battery drain is where this becomes personal. Your phone promises all-day battery because the software swears it knows how to be efficient. But many apps run background tasks that technically aren't active. They check for updates, refresh data, track location, occasionally. Each action is small enough to look harmless. Together, they drain power like a slow leak you never see. Then there's memory pressure. Apps ask for memory preemptively, not because they need it now, but because giving it back later is inconvenient. The operating system allows this, trusting it can clean up when needed. When it can't, everything stutters. You blame the hardware. The software stays quiet. Even animations are part of the deception. When you tap a button and something moves instantly, that motion often starts before the real work does. The animation buys time. Your brain relaxes. The app finishes loading in the background. If it fails, the animation just keeps dancing until it can invent an excuse. Progress bars are the most honest liars of all. The first 90% flies by. The last 10% takes forever. That's not accidental. Software rushes to reassure you early, then quietly struggles when the hard part arrives. This dance works because hardware doesn't complain. It can't. Chips don't argue. They just heat up. Fans spin. batteries degrade, and as long as nothing crashes, everyone pretends this system is stable. But it's not stable. It's balanced. Balanced on assumptions that workloads will stay predictable, that users won't notice micro delays, that hardware will absorb the stress silently. The moment one of those assumptions breaks, the lies start leaking through. And that's when things get interesting. This is the point where the system stops bluffing, because eventually the hardware runs out of patience. Thermal limits are one of the first cracks. Chips are fast, but they're not brave. When software keeps pretending everything is fine, the CPU quietly disagrees by slowing itself down. Not because it wants to, because physics forces it to. The operating system calls this thermal throttling. That name makes it sound intentional, responsible, almost polite. What it really means is the lie worked too well for too long. You see it when a laptop that felt powerful in the morning becomes sluggish by afternoon. Same software, same files, same user. The difference is heat. The hardware has decided it can no longer keep up with the story software is telling. Then there's memory collapse. Modern systems promise abundance. Dozens of apps open, hundreds of tabs, seamless multitasking. Behind the scenes, the operating system is compressing memory, swapping data to disk, and gambling that you won't need certain things again soon. Most of the time, you don't notice, until you do. An app reloads for no reason. A tab refreshes and forgets what you typed. A game stutters even though nothing else is running. That's not randomness. That's the moment the system quietly dropped something to keep the illusion alive. Storage exposes another lie. When your system says a file is saved, it often means, I promised to save it. The data sits in a temporary buffer, waiting for a calm moment. If the power cuts out before that moment arrives, the truth surfaces. The file was never really there. And then there's latency. As workloads grow heavier, delays stop being hideable. Animations slow down. Touch inputs lag. Audio crackles. The software keeps smiling, but your fingers know something's wrong. This is the turning point. When the cost of lying exceeds the benefit, hardware responds the only way it can, by enforcing reality. Slower clocks, lower performance, shorter battery life, earlier wear. The machine ages faster, not because it's weak, but because it's been overpromised. Ironically, the more powerful hardware becomes, the more aggressively software exploits it. Extra cores invite more background tasks. Faster storage encourages sloppier memory use. Bigger batteries justify more constant activity. Progress doesn't remove the lies. It raises the ceiling on how long they can continue. And right now, we're closer to that ceiling than most people realize. So here's the uncomfortable takeaway. Your computer isn't slow because it's weak. It's slow because it's being polite. It's honoring a social contract that says software gets to exaggerate its needs, hide its delays, and smooth over reality as long as the user feels in control. As long as nothing visibly breaks, as long as the illusion holds. And for decades, that trade worked. But the gap between hype and reality is widening. We sell machines based on peak performance numbers that almost never happen. We design software assuming unlimited resources, instant networks, and patient hardware. We optimize for how things look, not how they actually behave under pressure. The lies compound. AI workloads quietly consume entire cores. Background sync never sleeps. Interfaces grow heavier to feel more alive. And each layer trusts the next one down to absorb the cost. Until it can't. The risk isn't that computers will suddenly fail. It's that they'll degrade so gradually we normalize it. Shorter battery lifespans, more heat, more fan noise, more just restart it moments. We adapt to the symptoms instead of questioning the system. And there's a deeper question hiding underneath all this. If software must lie to feel fast, what happens when we ask it to feel intelligent? When decisions matter more than responsiveness? When delays aren't just annoying, but consequential? When systems act on our behalf instead of waiting for input? Do we want smoother illusions or clearer truth? Because hardware will always enforce reality eventually. Physics never negotiates. It only waits. The real choice is whether we keep building systems that get better at hiding that moment or ones that help us see it coming. Next time your computer says, everything is running smoothly, ask yourself a quiet question. Smooth for who? Done watching. If you like this video, hit subscribe for more cool stuff.